Welcome back to our course on data modeling in data warehouses. So, I don't know if any of you had this doubt in your mind, right? Why do I need to learn data modeling in data warehouses as a separate independent topic? If you have been a developer for a while, I'm sure you'd have built applications that pull data from a database and serve that data back to the consumers. So obvious ones would be that, let's say there is a product catalog and you want to show the products to the consumer. You have a user who has placed some orders and you want to show the list of orders for that consumer. So those are traditional use cases for which I'm sure you would have done some kind of schema design and then query design to get the data elements that you wanted in the most efficient fashion. So why can't we just apply those same principles in a data warehouse? Fundamentally, a data warehouse, the core of it is a database. And if you are comfortable with one database, let's say a MySQL or a Postgres or a MongoDB or a DynamoDB, uh, there seems no reason that you cannot apply those same concepts of data modeling on a data warehouse. And this is exactly the mistake a lot of people do. And let me tell you why the core database in a data warehouse is fundamentally different from the kind of databases that you use, which you integrate with your application to serve the data back to your front end for various kinds of scenarios. So, the kind of database that you traditionally use, like a MySQL or a Postgres, are essentially what are called OLTP databases. Whereas in a data warehouse, what you end up using is what's called an OLAP databases. So many of you would have heard of these concepts, probably understand them to some extent. But the one key difference between these two, and those are obvious when you look at the two acronyms as well. The T and the A are different, right? So the T in OLTP stands for transaction processing. The A essentially stands for analytics or aggregation. So the two databases are fundamentally different. One of them is catering to transactions and the other is catering to aggregation. And that is what fundamentally makes the database in a data warehouse different from a database that you use with your applications serving your consumers. So before you understand anything about the data modeling in a data warehouse, you really need to understand how is an OLAP database different from an OLTP database, and that's what we're going to dive into. So go back to your usage of databases, right? Your database was powering queries that were serving data to a large number of consumers. So if you were building a commerce platform, right, your catalog would be surfaced to a large number of users. All of them will actually look at small part of the catalog. If you had a database that had user orders, then every user is only going to get part of their orders. So the user for a traditional database that you essentially work with are numerous. On the other hand, look at who are the consumers of a data warehouse, right? You'd see that there are very few people who actually consume a data warehouse. There's a marketing team, there's potentially a data science team. All of them are looking at that data, but if you add all of these people up, it's going to be still a very, very small number of users running a much smaller number of queries than your traditional OLTP databases. Now look at the kind of operations they do. In the traditional database or the OLTP database, you essentially have people just doing filters. You have a large amount of data, whereas a user is you're looking for a small part of that, and they filter that data, and that data is served to the user, typically through a fancy UI. On the other hand, look at what operation do your marketing team or your analytics team care about in the data warehouse. They are essentially looking to generate insights, which is essentially not the raw data, but taking a bunch of records and creating some kind of a magic on that to get a metric. It could be an average revenue. It could be a trend of revenue over a period of time. Those are the kind of things that they really care about. Essentially, that's what you look in the output also. Your output for a user would essentially be a small list of items. Those items could be orders, those items could be some product that they want to purchase. On the other hand, the output for your business team or your marketing team or your data analytics team are essentially dashboards and reports, never the raw data. It's typically some kind of an aggregation on top of that. Now, because the users are different, because the type of operations they perform are different, because the type of output they need are fundamentally different, the OLTP databases and the OLAP databases actually lay out that data in a very different fashion. So the OLTP databases would typically follow what's called a row-oriented layout, where all data for a particular row would be placed together. On the other hand, because an OLAP database, the primary use case to look at a bunch of records and drive some insights, and it would be typically be the same column. So the data is laid out in columns. So records for the same column, the column could be, let's say, the price. They are essentially stacked together. So this is what we're going to go deeper in this lecture, and we'll again start to go deep by looking at the users. So you have to understand the users very well, right? OLTP databases, you will have a large number of users. This is the primary database of your platform typically, right? And it's used by the primary users. So if you're creating an e-commerce platform, your shoppers, they will get the data from this database. If you're creating a learning platform like Udemy, students will actually get the data, right? Of what courses are there, what have you enrolled on, what, where are you in your specific journey of a course. Those are the kind of things that you will fetch from the data. You will perform transactions on this data. You will create one order. You will make a purchase of a course. And key thing is that you will, in all these cases, you're either retrieving a small number of records or you're changing a small number of records. Look at what you will do in a data warehouse, right? So there will be a small number of users, either business users or secondary users of the platform. For example, in a platform like Udemy, you can consider teachers who will be using an OLAP database, because I need to look at the statistics of where are students dropping off in the course. How many students come in and look at a course and how many of them eventually go on and purchase it. So this secondary user of the platform, much smaller in number, not looking at raw data, but looking at aggregates, insights. Now, the secondary user may also require OLTP use cases, in which case those gets are from the OLTP database. But secondary users are more likely to need an aggregation or an analytics use case, which essentially gets served by the OLAP. Marketing users, business users will almost always need the analytics use cases. Now, the key thing about this use case is that I will need to touch only a few columns, right? For example, I take my example. I want to see where a student is dropping off. So essentially, in order to get that information, all I need is basically some column which says last touched. And I'm going to do just some kind of an aggregation of the last touched. So this is basically how the use cases are different. And that translates into the queries that you need. In the case of an OLTP database, it's all about filtering. Fetch details of this product. I'm looking to buy iPhone 13. Fetch details of that. I'm looking to purchase this course, data modeling and data warehouse. So give me the details of that course. You could have more broad filters when you're trying to browse. Oh, get me the cheapest 10 courses on Java with rating greater than 4. The key thing is that there are a large number of records, and all you care about is getting a small number of them that you want to know more about. And in these cases, you're essentially going to get all the columns for those records. That's what you need. You need to know everything about this course, right? The description, the instructor, the duration, the price, everything. And when you go and do a purchase, you're going to update just one record. You're going to create one order entry in the large order table. So that's what OLTP is all about. Look at OLAP. It's completely different query structure that you're going to have, right? I want to get the average review score of my courses. Now, what does that mean? There is a column called review score, and all I'm going to do is I'm just going to do a summation, divide by count, get my average. Do I care about other attributes of my course? Not really. I want to get total revenue for course X. Again, all that means is that look at the transaction table and just look at the revenue column, and then just read the revenue column and do a total on that. There could be more complex aggregations. I want to know my top selling products for this year and I want to order them by revenue. Again, all I care about is the revenue column, the year column, and then the product column. And when I'm going to look at the data, I'm going to only look at the year as a filter, and then I'm actually going to do an count on the revenue column. I will not care about anything else in that large transaction table with a large number of columns. So if you now see the query structure, it is very fundamentally different, right? I'm always going to retrieve a few columns, but I'm going to touch a large number of records. I'm going to touch all transactions for this year in the last query. In the case of average review score, I'm going to actually touch all the reviews for my courses, across years. But I'm only going to touch one column. And as you can look at it, right, you don't make updates here. There are hardly any updates. And that's what fundamentally is different, right? The user is different. What he needs from the database is different. That's a query structure and the update structure for both OLTP and OLAP. And that essentially will get us to the